Hey, good morning, everybody. Thank you, Shannon. So, like Shannon said, what I'm going to be really doing today is kind of going through a high-level overview of what Stacks is, how it works, what makes its architecture unique compared to something like Ethereum, and then why that might be a good thing for blockchain technology and for the kind of things we want to build on blockchains. And then I'll finish up by going through just a little bit of a code demo for clarity so you can kind of get introduced to that. So quick background about me, the developer advocate at the Stacks Foundation. I've been a developer for about 8-9 years. I got into Web3 stuff about 2 years ago, 2 to 3 years ago, started on Ethereum and Solidity, and then found Stacks about a year ago and just immediately got hooked on the architecture and how it is connected to Bitcoin, and really just kind of immediately jumped into building on that due to a lot of the stuff that we'll be talking about today. So if you are new to the Stacks world, this will be hopefully helpful for you to understand what it is, why you might want to consider building on it, what makes it unique. If you've been around Stacks for a while, most of this will probably be review, but hopefully it will give you kind of a new angle to look at Stacks and be able to communicate its benefits to other people. So the first thing that I want to talk about to kind of give some background and context for some of the unique advantages that we get with Stacks is I want to talk about the Dow hack, which was a big hack that happened to the Ethereum ecosystem in 2016, 2017. Basically, what happened here is there was this project called the Dow that got really, really popular. It raised tens of millions of dollars. And then there was a vulnerability in the smart contract where, so one of the functionalities of the Dow is that people could spin up their own sub DAO, and what that would allow them to do is transfer the funds that they had allocated to them on the main DAO and transfer them down to their sub DAO. But what this attacker was able to do is he was able to exploit a couple of vulnerabilities, one utilizing reentrancy and one utilizing a fallback function, and combine those together to basically drain the DAO of, I think, like $65 million worth of Ethereum. And we'll go into exactly what the reentrancy attack looked like in a little bit here. But the thing that I want to focus on now is what this actually did to the Ethereum ecosystem. So because of how large the DAO project was and how much money the hacker actually stole versus how relatively young the chain was at the time, this kind of shook the entire Ethereum chain to its core. And eventually it resulted in this contentious hard fork of the chain. And the reason that was such a big issue is because blockchains are designed to be an immutable ledger. That's the entire point of them. And so this kind of brought up this question of, well, is it more important to maintain immutability, or is it more important for the chain to survive? Because arguably, if they had not done that contentious hard fork, Ethereum wouldn't exist right now, because the proportion of the funds that were stolen compared to the total funds on the network were that big. And so a lot of people have used this and other similar attacks to say, this is why Web3 is dangerous. This is why this stuff is never going to work. And that to me is kind of like throwing the baby out with the bathwater, where instead of looking at how we can just maybe approach this a little bit differently, we're kind of just throwing out the entire thing. When it turns out that there's actually a lot of things we can do when we design both a blockchain and smart contract language in order to prevent some of those things from happening. So in order to illustrate that, let's look at the differences between like the Bitcoin chain and the Ethereum chain. So with Bitcoin, it doesn't really do much besides just be money. That's all it is. This was arguably the original blockchain. Its design is very, very simple. Bitcoin scripting language does not do very much. It's very difficult to change the Bitcoin chain. And so that gives us a couple trade-offs. One, it's very, very good at being hard money, which is what it's designed to do. And that's really all that it does. And that's all that it should do. The trade-off there is that when you compare it to something like Ethereum, you can't really do all that much with it. Ethereum gives us all this functionality like DeFi, NFTs with smart contracts, and it lets us do a lot, and it lets us activate the Ethereum money a lot more than we're able to sort of activate the Bitcoin money. The Ethereum money at the moment, as it stands, is a lot more productive than the Bitcoin money. There's more capital locked up on the Bitcoin network. It's the longest running blockchain. It's the most secure blockchain. It's by far the most popular and well-known blockchain. At this point, Bitcoin is pretty much a household name, but the trade-off there is that you can't do much with it. I would argue that that's actually a good thing. A lot of that kind of pushes a lot of developers away from Bitcoin and towards Ethereum. Ethereum obviously right now has the lion's share of Web3 developers. But what a lot of people say is that, well, Bitcoin's not interesting to me as a developer because I can't really do much with it. And so this leads us back to why was the Dow hack so crippling to Ethereum? And the primary reason that it was is because it financially impacted the Ethereum chain. Because with Ethereum, the trade-off that you get with all of that functionality is increased complexity and increased attack vectors. So we read about attacks on Ethereum. Excuse me, let me clarify. We read about attacks on smart contracts that run on Ethereum all the time. With the Dow hack specifically, a big part of the reason why that was so damaging is because of how it financially impacted the chain. So then, rather than saying, okay, well, let's throw Web3 out because this is not going to work because this kind of stuff is happening all the time. Why even have an immutable blockchain if you're just going to change it anyway? All valid points, but there's a little bit of a middle ground here. And that's where Stacks comes in, is what if we separated out the money and the programming layers? So that general big picture, high level architecture decision is sort of what Stacks is built on. It's built on saying, how can we keep Bitcoin without changing it, but also still unlock all of the capital that's sitting on it in a trustless, immutable, decentralized way without having to send your Bitcoin off somewhere else and trust it with a custodian in order to, say, do something like earn yield on it or use it to purchase an NFT, or eventually down the road, some of the use cases I envision, hopefully, are things like loans and mortgages, where your record of ownership for the house is tied to an NFT and your mortgage payments are automatically handled using a Clarity smart contract on Stacks. But all of that is ultimately being paid for and handled with your Bitcoin funds, and those don't ever have to actually leave the chain. So that's one of the things we'll talk about in a little bit. But that's sort of the high level, big picture reason for why Stacks exists, is how can we take Bitcoin and let it keep being Bitcoin, but also unlock all of that functionality? Because then the benefit we get here is, let's say worst case scenario, a DAO level hack happened to Stacks. That wouldn't really affect Bitcoin very much because everybody's Bitcoin funds would be safe on the Bitcoin chain. It would affect Stacks and it would be very damaging to the Stacks chain. But the underlying global money, the global settlement layer, would still be safe because all of the complexity and the smart contract functionality is being handled separately on a different chain, and in this case on the Stacks chain. So that's sort of the high level overview. So let's go into a little bit technically about how this actually works. So the primary way that we're able to do this is through the consensus mechanism that Stacks uses called proof of transfer. So I'm going to share my screen real quick, just because getting a little bit of a visual into how proof of transfer works can help. So this is a diagram that shows how, at a high level, how proof of transfer works. So what I like to do when I explain proof of transfer is compare it to how Bitcoin works. So the proof of work concept on Bitcoin personally is, I think, a much better consensus mechanism than proof of stake is. And the primary reason for that is that the consensus and the resource that you have to spend in order to create more Bitcoin exists outside of the Bitcoin chain. To me, with proof of stake, I know there are very good arguments against this, and there are a lot of people that would disagree with me. This is just the conclusion that I've come to from my research and one of the reasons I switched to Stacks. Proof of stake to me just seems like a recreation of the system that we already have, where the more of the chain's resource, the monetary resource, in this case, Ether, that you own, the more influence you have in that ecosystem. And again, I know there are arguments against that, but that's just the direction that I see proof of stake heading. With Bitcoin, the difference is with proof of work. The resource that you have to spend is different in two ways. One is it's external from the chain, and two, it's constant. You can't accumulate it. So you have to burn energy in order to make more Bitcoin, and you always have to burn more energy to create more Bitcoin in order to mine new blocks. With Ethereum or proof of stake, you get to accumulate more and more Ether. You don't have to get rid of it and continue that resource spending in order to mine more, or mine more blocks. So Bitcoin, high level, you spend energy in order for a chance to earn Bitcoin by mining a new block and getting the block reward. Stacks takes that one level further and then allows you to spend Bitcoin for a chance to mine a new Stacks block and get that block reward. And it does this through this proof of transfer mechanism. So one quote that I like a lot when I think about Bitcoin, we can attribute this to Jude Nelson, who's one of the core engineers that works on the Stacks blockchain, is that Bitcoin is not a waste of energy, it's just underutilized. So one of the big arguments we hear against Bitcoin is this energy usage. But when you look at it myopically like that and just focus on this single issue of energy usage, you lose a ton of context. So if Bitcoin is useless, then the energy argument makes sense. We don't want to waste that energy on something that's useless. But if Bitcoin is functioning both as a global, immutable, secure, hard money layer and as a global, secure, immutable, hard settlement layer for smart contracts, then that energy usage all of a sudden starts to look different. There are lots of things right now that use more energy than Bitcoin, and we don't bat an eye because we understand that they are valuable things. So that's kind of the key that comes in there, is this unlocks additional functionality for Bitcoin, again, increasing its value without actually having to modify the chain itself. So the way that proof of transfer works is you take this Bitcoin, you spend it, you send it to a specified address, and then that puts you in this weighted verifiable random function. So the more Bitcoin you spend, the higher likelihood you have of being the newly elected leader and being able to mine the next block. So let's say you win and you get to mine the next block, then you get rewarded with that newly minted stacks. But where's that Bitcoin go? The Bitcoin gets transferred over to stackers, as you can see here on the right. A lot of people get hung up a little bit here. So the stackers, this is not proof of stake. The stackers have no influence on the consensus mechanism of the stacks network. That is all in the proof of transfer process, the transferring of the Bitcoin and the leader election there. The stackers are a little bit of a separate process where it incentivizes people to lock up their stacks in the network in order for them to earn a reward in Bitcoin, which increases the economic security of the chain. So it's not contributing to the consensus of the chain at all. It's adding to the economic security of the chain, which has network effects, because the more value that's locked up in a chain, the more attractive it is to people. And then two, it also has a secondary effect of being a signal to new miners that want to see what the real stacks chain is. Let's say hypothetically somebody tried to fraudulently create a new stacks chain, but there was no stacks locked up on their network, whereas there are tens of millions of stacks locked up on the actual stacks network, hypothetically. That's a good signal to them, okay, this is the real chain. So it kind of contributes to security in those two ways. And so the big unlock that this gets us is it lets us build a financial system and economy trustlessly without anybody actually having to use the stacks network, because the final thing that we get as a result of this and as a result of the clarity language is that we get visibility, read access into the Bitcoin chain. And the second part of that that's being worked on right now, that will be the next step into that, is write access to the Bitcoin chain. So eventually what this will allow us to do is we can monitor a certain Bitcoin address for certain activity in our Clarity smart contract. We can take some action on the Clarity smart contract network, do what we need to do on that side, handle the complexity of the smart contract, and then we can take another action on the other end of that on the Bitcoin network. That's sort of the big picture unlock. We're not quite there yet. There's still some work to be done to unlock that right access on the Bitcoin chain. But high level, that's what it's going to allow us to do. And again, I want to hammer this point, it's going to allow us to do that without affecting the underlying money and settlement layer at all. So the final thing that we get with this is we get to leverage some of Bitcoin security. It's not to say that Stacks is as secure as Bitcoin just because it settles on top of it, because that's not true. But by settling all of the transactions on Bitcoin, by the way, a little bit of a side note here. One of the reasons that Stacks is not a sidechain or a merge mine chain is that or a checkpoint system, is it's not like these blocks are just being written to Bitcoin arbitrarily as just like a kind of an afterthought, and there's no peg to Bitcoin. What's happening is that the hash of the Stacks block is getting recorded to the Bitcoin chain as a Bitcoin transaction as part of the mining process. So it's actually not possible to have a Stacks chain without that settlement on Bitcoin. So one of the big security benefits that this gets us is that it's at least as hard to reorg the Stacks chain as it is to reorg the Bitcoin chain, because that history has been recorded. And then the other benefit of that is if you were to try to recreate a private copy of the Stacks chain, you would have to decouple it from Bitcoin, which arguably would make it not Stacks anymore. So it's extremely difficult, arguably impossible, to create a false private Stacks chain without broadcasting it to the entire network, because you have to write to the Bitcoin chain in order to do it. So anybody's going to be able to see an attack like that coming in public, because that's the way that the mechanism works. So that is sort of the high level overview of proof of transfer and how Stacks actually gets connected to Bitcoin. So going back to how we can have visibility into the Bitcoin chain and the smart contract language that is used on Stacks, What we use is called smart contracting language called Clarity. And Clarity is specifically designed to make it easier for developers to write safer, more secure smart contracts. And so there's a few properties that it has that allow it to do that. The first, which is going back a little bit to what we originally started with the DAO, is that Clarity does not actually allow reentrancy. So that hack that we went over with the DAO would not actually be possible on the Stacks network because that's just an anti-pattern in Clarity. It's not actually allowed. Coupled with the fact that Clarity also doesn't have fallback functions. So there's a little bit of a two-part attack involved in this. I'll post this link in the chat real quick because this is a good overview of how the attack actually worked, and it's relatively simple. So right here, the vulnerable smart contract, this is a simplified reentrancy attack scenario, has 10 ETH. An attacker stores 1 ETH on it using the deposit function. An attacker calls the withdraw function and points to his malicious contract as a recipient, and then the withdraw function will verify it if it can be executed. Do they have 1 ETH on their balance? Yes, because they deposited it. This is all legit so far. So then it transfers 1 ETH from the contract to the malicious contract. And this is where it starts to get a little bit hairy, is at this point in the Solidity contract, the attacker's balance has not been updated yet. So what will happen now is that the malicious contract will have a fallback function that will then just immediately call right back into that withdraw function. But because the balance has not been updated yet, they're going to be able to just continue pulling 1 ETH out over and over again until either they run out of gas or until the contract runs out of money. So basically that process is just going to happen all over again. In Clarity, this process would stop right about here at this second bullet point. And then the process would halt because they don't have any fallback functions, and so they don't allow reentrancy. So that's one advantage of Clarity right there. And this highlights sort of this is a specific example, but what I want to do is look at the bottom of this post, because right here, the end of this post has how to protect smart contracts against a reentrancy attack. So this is one of the big high-level goals that we have with Clarity, is we want to avoid needing these kinds of things. This is not good in a smart contract language. It should not. We want to minimize the extra work that developers have to do in order to prevent stuff like this from happening. So the DAO is the most famous example of this, but if we go back up to the top of this code, there's a section, is reentrancy still a significant problem? There's a lot of these that have happened relatively recently. And so there's tens of millions of dollars being lost because of this single issue. And this is, I'm harping on this one thing because it's a really good example of just a design decision that can be built into the code that would protect tens of millions of dollars of people's money. So it highlights a big high level goal of Clarity is when we're working with something that is, one, immutable, and two, handling people's funds and assets, we want to make it as simple as possible for developers to write code that is not going to be dangerous to that user. So this stuff right here, it's not to say that you can't prevent this stuff in Solidity. You can, but you have to take extra steps and you have to be very specific and very intentional about how you're going to do it. And what Clarity tries to do is it tries to shift that intentionality and that explicit code writing from the developer to the language itself. So which kind of leads us to a second part about Clarity, is that everything you do in Clarity is extremely explicit. So there's not a lot of implicit functionality in Clarity like there is in Solidity. Where that comes in is Solidity is an object-oriented language, and so there's a lot of inheritance there. When you write a contract or write a function, a lot of the times what you are doing is you are inheriting functionality from an external contract, and you're getting all of that functionality in your code, and it makes the code a lot cleaner, and it makes the code a lot shorter. But what it does is it hides a lot of functionality behind this implicit inheritance. Clarity is not object-oriented. It uses composition instead of inheritance. So the trade-off there is that Clarity code is usually longer. You have to be more explicit about what you're doing. But I would argue that in a smart contract language, that is a benefit and that's not a drawback. That we should want that. We should want to know exactly what our smart contract is doing every single step of the way. And Clarity allows us to do that much better than Solidity does. So where in Solidity we might have inheritance, in Clarity we have something called traits. And what we can do with traits you can think of them as like template smart contracts. And we can implement those traits into our smart contract one at a time, depending on what we want. But all that trait is going to do is provide a framework for how we have to build out our contract and provide a standard for it to stick to. So like fungible tokens and non-fungible tokens are a good example. They each have their own traits that the community has settled on as standard that are live on mainnet. And what you can do is you can implement those traits in your own smart contract. And what it will do is it will ensure that your smart contract adheres to this general structure of the higher level trait of the NFT. So it'll ensure that you have functions like mint, burn, transfer, all that stuff. But you are still required to actually implement the functionality of those functions. So you're still not getting that hidden functionality, even with the trait. All it's doing is helping to make sure that you stick to a certain defined structure. Excuse me. One of the other big benefits of Clarity that gets talked about a lot is Turing incomplete. That is a very loaded term, and there's a lot of complexity and computer science that goes into what that actually means and what the benefits and trade-offs are. But the big takeaway for that is that Clarity does not allow for unbounded loops like while loops or recursion. That's kind of the big high-level advantage that we get from being Turing incomplete, is that there are no unbounded loops in Clarity. So the benefit that we get from this there's a couple benefits we get. First, we can know with certainty what a program is going to do without actually having to execute it. So because Solidity is Turing complete and does allow for unbounded loops, there's no way to know exactly how much gas a contract is going to use or what exactly is going to happen before you execute it. With Clarity, because it does not have those unbounded loops, we know exactly what it's going to do, and we can cost analyze the entire call graph of whatever function we are calling, and we know with certainty that it's going to end at some point. We actually don't have that assurance with Solidity. So another relatively well-known hack happened to a project called Govern Metal. What happened to this project is that it got so popular that one of the function calls, in order to update an array in the Solidity code, it got so large that in order to update it, it actually costs more than what Ethereum currently allowed for gas costs. And so that it just died. It just kind of became unusable, and it actually required them to change the way that they handle gas fees. And so because of Clarity being decidable and not Turing complete, we have the ability to sort of analyze before we call it and see exactly what's going to happen to avoid problems like that. So it's not to say that being Turing complete is a bad thing, but the argument that's being made here is that it's a bad thing for smart contract languages because of their public immutable nature. We want to be able to know with certainty that those are going to end, and things like recursion and infinite loops are not something that we want in a smart contracting language. One other big benefit is that all functions in Clarity must return a response. So some of the low-level Solidity functions, they actually won't bubble up error codes. And so a lot of the times this can lead to extremely annoying issues for the developer because their code can fail silently without them knowing. So that's, again, not possible in Clarity. If you try to write a function that doesn't return something in Clarity, the contract will not be considered valid, and you wouldn't be able to deploy it up to the network. And then one other thing that I really like about Clarity is that it's interpreted rather than compiled. So the smart contracts that you write, they are going to be deployed up to the chain as is. There's no compiler step. So this eliminates one, compiler bugs, and two, it makes sure that the actual contract that you have up on the chain is human readable, and you don't have to have this middleman step of trying to decompile it and make it human readable that way. So one last thing, this is not necessarily a Clarity feature, but it is a Stacks feature. It is called post conditions. And I want to jump over to this tweet that Jamil from Gamma made. And he sort of highlighted the need for post conditions. And I'll post this into the chat as well. But what post conditions allow us to do is they're a feature on the Stacks chain that the client is actually implemented on the client side. And so they're designed to protect users. So what post conditions will do is, let's compare it to something like MetaMask, where you sign a transaction or initiate a transaction, and this is what you're seeing. This does not really mean much, even to a developer. This isn't going to mean very much. But with Stacks, this is what the post condition might look like. So you initiate a transaction, and the post conditions are set up so that it will tell you right here, you're going to transfer less than or equal to this amount of stacks, and another address is going to transfer this non-fungible token. If these two things don't happen, the transaction will abort and you won't be out anything other than the transaction fee. And so this is, again, a huge benefit in Stacks that I like a lot, is just this another feature that's built in order to protect users and protect them from losing funds. Again, this is not a Clarity feature. That's something that people often trips people up. This is actually implemented on the client side. So you would implement this in something like stacks.js, which is a hero tool that Joe will be talking about here in a little bit. You would implement this as the client-side developer in order to protect the user from potentially malicious smart contract. So those are kind of the big high-level benefits of Clarity. All this basically with the high-level goal of writing smart contracts that are as safe and secure as possible to protect users, because ultimately we're handling people's assets here. And so it's important to write code that, one, is extremely clear about what it's going to do, it's easy to write it in a safe way, and it's as secure as possible. So what I want to do now is switch over and just do a simple code demo to kind of walk through the basics of Clarity. I'm going to stop sharing here and start sharing something else. So what we're going to do here is we're going to actually use Clarinet a little bit, which is one of the tools that Hero develops. Again, that Joe will be talking about. There's a whole suite of tools that are kind of indispensable when it comes to writing stacks, and Clarinet is probably my favorite one of those. Joe will give an overview of what it does, but basically it allows you to create sort of an all-in-one stacks development environment for your Clarity smart contracts. So what we can do is we can start a new Clarinet project. Go ahead and switch into there, and we will open that up in VS Code. And you can see it created a bunch of stuff over here. Let me move this window over. Actually, let me switch one more time. Okay, so we've got a VS Code file here. And we've got this contracts folder. What we want to do now is we are going to create a new contract test. And that's going to create this Clarity file here. So what I want to do here is I want to just go through and kind of walk through a couple of the basic features of Clarity, because especially if you're coming from Solidity, Clarity is weird at first. It's got a little bit of a learning curve because it has such a different syntax and style of coding. But what you'll find is that the more that you use it, the nicer it starts to feel. And so the first thing to keep in mind is that Clarity is a Lisp-like syntax. And so there's lots of parentheses, which again, if you're coming from a language like Solidity or JavaScript, that's going to look a little bit weird. It's going to be structured a lot differently than what you're used to. So it's going to feel kind of funky at first, but you're going to get used to it. And so a good way to think about it is you can think of Clarity code as lists inside lists. Everything in Clarity is just a function, and then you pass in those functions as arguments to other functions. So there's a big functional programming leaning to Clarity rather than like more of an imperative leaning. So let's look at how we might do something just like a simple addition function. If we want to do something like 3 plus 2 plus 1. In JavaScript, we would pretty much just write it like that. In Clarity, what we're actually doing here is rather than adding like that, we're going to open the parentheses to start, and I've got GitHub Copilot, so I don't know what craziness it's going to spit out, but with this one, it actually did it right. So what we're going to do here is in Clarity, everything is a function. So all we're doing here is we're calling a function called +, whatever you want to call it, and we are passing in these numbers as parameters to it. So if we print this out, actually this isn't going to work, but yeah, if we were to run that, it would spit out, it would give us 6, because what it's doing is it's adding these numbers together. So that's kind of how, that's one thing that's a little bit weird, is that everything in Clarity is a function. And so there's not technically like operators. What you're actually doing is you're calling an addition function and passing those numbers in as parameters. Another example is we can call a concat function, and we can type in something like this. That one's not quite right, but we can pass in, well, I guess actually we could do it that way. We could also do it this way, pass in the space right here, and that's going to concat those two together and return us a string that says hello world. So We can also nest things. So let's say that we want to do something like we want to say 5 times, and then like we want to add together 2, 3, do 5 times that. In Clarity, how we would write that is for the first thing that we need to do is we need to call the multiply function, and the parameters that we're going to pass into it are 5. And then we're going to pass in the result of calling the add function on 2 and 3. And that's going to give us the same result as what we get right here. And then the other thing to keep in mind is that Clarity is a strongly typed language. And so type checking is built in. It doesn't allow for mixed types, and you have to declare the types when you're defining variables and when you're defining function parameters. And again, another feature that just makes it simpler to write secure code, so the language itself is doing more work for you as the developer. There's a few different types in Clarity. One other thing that I'm going to link to, because it is super, super helpful for understanding the language, is I'm going to link to the Clarity book, which will go over a lot of the stuff that we're going to be talking about today, but in much more detail. And the cool thing about the Clarity book is that you can execute the code that you're writing inline in the browser. And so that's a really good learning resource for learning more about Clarity. But some of the primitive types are, we've got ints, we've got unsigned integers, booleans, and then principals. So principals are stacks addresses, and they look like this. So this was a testnet address because it's ST, and we prefix it with this little single quotation right here. That tells stacks that it's a principal, or another way to think about a principal is an address. Integers, straightforward, but unsigned integers are prefixed with a U. Unsigned integers are positive only. And then we've got sequences. So a sequence is basically just it's multiple values in order. So like a string, that would be a sequence. A list would also be a sequence. So earlier, when I talked about how there's no recursion or unbounded loops in Clarity, what you can do is you can iterate. So you can iterate over lists of defined data. You just can't do an unbounded loop where you don't know when it's going to end. You just can iterate over a defined loop over a defined amount of data. And so lists are one of the things that we can iterate over. Tuples are another composite. Tuples, which you can think of similar to an object, where you might have an ID of 5 and then a name. I'm going to do here is this U is defining this as a UTF-8 string instead of a ASCII string. Then we might have age with an unsigned integer of 30. So that's a tuple, which is just a data structure. You can actually make these keys right here as complicated as you want. So these keys don't just have to be text like this. And then one of the other things to think about in Clarity is optionals. So there's no empty values in Clarity. Again, like before, everything has to return something, but there are going to be some cases where a function might return one thing in one scenario, but it might return nothing in another scenario. And so for that, we have optionals. So we could write this out as sum u5. And then what we could do here is if we wanted to then handle this result and actually unpack it, what we could do is we could use the unwrap function, pass this in, and then if this does not contain anything, if it doesn't return anything, if it returns none, which is another type that we have in Clarity, then we can return some sort of error here. And so that's kind of how we can handle those response types in Clarity. So what I want to do right now, real quick, before we wrap up, I just want to really quickly go over building just a very basic contract to kind of cover some of these types and how we might handle data, keywords, and functions. This is just going to be super high level. We're not even necessarily going to go over and make sure that it actually works correctly. So just take what we're about to do with a grain of salt. This is just kind of a quick off-the-cuff code demo. What we want to do first is we're basically going to just build out a super simple message board where you can post a message to the Stacks chain. So the first thing we need to do is we need to define a constant. And a constant is just what it sounds like. It's just a piece of data that doesn't change. We're going to call this contract owner. This is a super common pattern that you'll see in Clarity. What we're doing here is we are saving the transaction sender, which in this case is this is going to get run. This line right here is going to get run when we actually deploy this contract. So what this is going to do is it's going to set this contract owner to whoever is deploying the contract, which in this case is going to be the sender of the transaction. This is a keyword that we have in Clarity. So that's what that line is doing there. You'll see that all the time in Clarity smart contracts. Next, we want to define another constant to basically set the price. Hypothetically, let's say that you have to pay a certain price to write this message to the blockchain. We're going to define that price here, and we're going to say U5, and then we are going to do 5 million. And what this is this is microstacks. And so there are 1 million microstacks per 1 stacks. And so this is how we would denote 5 stacks or 5 million microstacks. Next, we're going to introduce another data structure called a map. This is similar to a mapping. This autocomplete makes it way more complicated than it needs to be. I do this manually. You can think of similar to a mapping in Solidity, and we're going to define a map called messages. And what that is going to do is that is going to store a mapping of data that will map a principal, which remember is a stack's address. That will map a principal to our message that we want to type, which in this case is going to be a type of string UTF-8 with a max length of 500. So that's what we're doing here is we're setting up a map called messages, where each entry in that map is going to be a principal that has been assigned a certain string, and that's the message that they paid the right to write to the stacks chain. Next, what we need to do is we would need to define our public function. So in Clarity, there are public, private, and read-only functions. Public functions can be called from external contracts, and they can modify data. Private functions can modify data, but they can only be called from inside the smart contract. And then read-only functions don't modify any data. And if you try to modify data in a read-only function, the contract will not be considered valid and you won't be able to deploy it or run it. The checks will fail. So we're going to define a quick public function here called write message. This is going to take in a couple of parameters. First, it's going to take in a parameter called message, and that is going to be a principal. Sorry for the GitHub Copilot throwing all these comments everywhere, trying to guess what I'm going to do. Excuse me, sorry, not principal. That is going to be a string with a max length of 500, corresponding to the piece of data that we put in the mapping up here. So now this brings us to another concept in Clarity. We're going to open up with a begin block. So again, remember that in Clarity, everything is a function, and functions just sort of get passed to each other, or these lists of information that just get passed to each other. So what we're doing here is we're defining a public function called write message, and we're passing it a parameter of message, but at a higher level, what we're doing is, again, we are calling a defined public function, and we are passing it the parameters of the function signature, the name of the function and the parameters, and then the second parameter we are passing to define public is the actual function itself. And so this begin block will execute everything that we're about to write in order, and it will basically turn our more complex function into a single parameter that can be passed as the function body to this defined public call. So what we're going to do here is we are going to call try and stacks transfer. We're going to transfer the price. We're going to transfer it from the sender to the contract owner. And so what this try block is a control flow statement. And what's going to happen here is if this succeeds, then the begin block will continue on to the next line. But if it fails, then what's going to happen is the execution of the contract is going to abort and revert. So one thing that's important to know in Clarity is if we had something that was written right here, if we had some code doing something right here, if this try block failed, this code would all be undone and it would revert. So that's another thing to know about Clarity is that if something fails, the entire function reverts back to the state that it was before, which again is just one of those things that's built in to make it safer to write code, is that you're not actually really permanently modifying any data until the contract function has successfully executed. So once that is successful, then the next thing we're going to do is we're going to set our sender's entry in the map to what they passed in as the message. And basically what we would do is on our front end, we would have this be like a form field or something like that. We would initiate this transaction with something like stacks.js. And then they would be able to set this message. And then finally, you're going to just return a simple OK saying that the message was written. So this is all going to execute sequentially. And if any of it fails, it's going to stop execution and revert back and return an error. So those are the basics. A couple more features of Clarity that I didn't go over that I'll go over real quick before we wrap up are they allow for native token type. So if I want to define an NFT, what I can actually do is I can define a non-fungible token called Pennycoin, and I can give that an identifier of a uint. So rather than having to deal with complex libraries like OpenZeppelin, where you're trying to adhere to the ER 721 standards or something like that with inherited code like that and doing external libraries, it's actually built right into the Clarity language itself, non-fungible tokens and fungible tokens. Again, that link to the Clarity book I sent is going to go over that in a lot more detail. This was just kind of, I wanted to introduce to you the fact that that is an option. So with that, I am going to stop sharing my screen. I don't know if I missed any questions in the chat, but it looks like we have one question right here. And so I saw this question last night, did not know the answer to it off the top of my head. So I looked into it. And the short answer is I don't actually know. I had a really hard time finding anybody that's using sponsored transactions right now. What I did find by searching on GitHub is that Magic Stacks, which is the BTC to XBTC bridge, it looks like they are implementing sponsored transactions in their code, but whatever feature that they're using them in has not been released publicly yet. And so I just happened to find it by searching out the Stacks.js code for initiating a sponsored transaction on GitHub, and theirs was the only project that I recognized that I could find that was using them. So for context, what a sponsored transaction allows you to do is it basically allows for somebody who is not the transaction initiator to pay the fee of actually writing that contract. So what a project could choose to do is they could say, I don't want my users to have to pay for this transaction. So you pass in the sponsoring address's private key into the Stacks.js call. You would not do that directly in the code. You would want to do that in like an environment variable or something like that. And then you would pass a couple other parameters like the fee you want to do. And what that would allow you to do is the user could initiate the transaction, but it will allow another third party to actually pay for that transaction. Okay, looks like we had another question pop up in the chat. How to call contract function from backend using only HTTP API. Main problem, how to sign this request from code. Can't find anything about it on docs, only high level things. Okay, this is a good question and one that I don't know off the top of my head. I know that one of the things we are working on right now is is trying to get people to build more libraries for other languages so that we can unlock more stuff like this. I'm going to put in my Discord username, and I want you to just send me a friend request on Discord and DM me so that I can help you kind of figure this out and look into it, because I don't know the answer to it off the top of my head, but it's something that I've heard mentioned before, and so I want to look into it and figure out the answer to this as well. And then this does bring up another point, that the docs are sparse right now. This is something that is currently being worked on. It is a priority right now. One thing that would be super helpful for anybody that is looking to contribute to Stacks is by basically contributing to the docs to help us kind of write tutorials, figure out the things that you would like to see in it that you think are missing. But this is something that is being worked on right now, and we are aware that the docs are pretty sparse. Up until the docs are a little bit better, I have this page, which won't directly answer this question, but it will provide sort of a starting point for people that are looking for just like a clear path of, okay, how do I get started? And then, yes, let me post another link in here real quick for jobs. We have a whole job board for the whole Stacks ecosystem, and that's right here. So you can find that right there. But cool. With that, I will cut out and let Shannon or Joe go ahead and take over.
Great.